The use of culverts has been prevalent for practitioners designing and installing watercourse crossings for quite some time now. Embedded culverts are becoming the new standard for culvert installation, as they greatly reduce the risk of blocking fish passage when they are installed correctly. By embedding culverts and designing them correctly, the natural stream bed can be extended through the culvert, which is beneficial for stream health and for the function of the watercourse crossing structure. Other key attributes of embedded culverts include that they are not as prone to erosion beneath the structure, as they can mimic natural stream conditions as well as water speed and flow. Embedded culverts can be prone to fish passage issues if not correctly designed and maintained, and are more easily blocked by debris or beavers than other types of watercourse crossing structures. Embedded culverts are typically circular, but a pipe arch or boxed culvert shape can also be used. Selecting the proper size of the culvert is key to its success. The diameter of the culvert must be able to accommodate the full width of the watercourse channel and manage the volume of water associated with high flow events. Sizing must also consider that the culvert will be partially filled with substrate that will occupy approximately 15 to 30% of the culvert diameter. The culvert must be long enough to reduce the amount of fill material entering from the road surface. If there are limitations on site for how long the culvert can be, a shorter crossing, such as an arch with a steel headwall, can be used, as the headwall will hold back road fill and ditch grade material. Other factors such as fill depth, culvert gradient, and road width also play a role in determining appropriate culvert length. When embedded culverts are being installed on slopes greater than 3%, the culvert must be anchored by placing larger substrate inside the structure and ensuring that this substrate is partially buried in the stream bed so that it is firmly in place. Proper placement of the substrate is important for fish movement. Steep gradients can result in high water speeds within the culvert that can limit or impede fish passage. Therefore, maintaining a consistent gradient that is representative of the natural stream bed is important. Key considerations: accurately replicate the natural stream bed conditions within the culvert. Mechanically compact the backfill adjacent to and within the culvert. Use a range of substrate sizes to ensure the stream bed is sealed. This can be done by washing finer substrate into the culvert once larger material has been placed inside. Sedimentation protection measures should be put in place to recapture any sediment that flows through to the outlet of the culvert. A clay cap should be used to create a seal underneath and around the culvert. Avoid installing embedded culverts where there is a bend in the watercourse, as this can cause erosion and debris issues. Also avoid sites that have very thin stream bed layers, as the substrate will not be thick enough to embed the culvert. Do not attempt to embed a culvert that has been previously installed by adding material to it. Embedded culverts need to have larger diameters and be installed more deeply to function properly. Do not fill the culvert with only large material, as this will cause water to flow around fill material instead of over it, and will decrease the water depth. Do not use only fine materials, since this can cause erosion and sedimentation. A mixture of substrate sizes are required to adequately fill interstitial space in the newly constructed stream bed. Best practices: when installing an embedded culvert, avoid steep gradients and match the slope of the culvert to that of the natural stream bed. Substrate within the culvert should match the substrate in the surrounding watercourse in both type and size. Make sure the depth of the water in the culvert is similar to the water depth both upstream and downstream of the water crossing area. Ensure that you're disturbing the smallest area possible during construction, and revegetate areas as soon as possible to provide erosion protection. Riprap can be used at the inlet and outlet of the culvert to maintain long-term integrity of the structure. Do not store materials or equipment on vegetation adjacent to the watercourse during installation. The embedded culvert should match the watercourse depth and longitudinal profile. You can gather that information by surveying the characteristics of the watercourse outside of the area of influence of the crossing, which is usually a minimum of 100 meters upstream and 100 meters downstream of the crossing site. It's important to properly compact backfill material in layers to prevent deformation of the structure over time. Geotextiles can be used to help prevent erosion of the fill material along the length of the culvert. As with all types of crossings, there are key times to avoid when working in watercourses. These include adhering to the restricted activity periods for fish and ensuring that high flow conditions are not in effect while working in and around watercourses. Site reclamation. Ensure the side ditch and the road water are not draining directly into the watercourse, as they can carry significant amounts of sediment, particularly during storm events. Revegetating exposed soils as soon as possible reduces erosion and sedimentation. If a culvert needs to be removed from a site, the same erosion and fish protection measures should be applied. Return the streambed to its natural state and ensure that no fill materials are left within the high water mark of the watercourse. Re-establish the natural streambed gradient through the disturbed area, as this is essential to successful reclamation. Remove all non-biodegradable materials and revegetate any exposed soils. Monitoring and follow-up. Regular inspections should be conducted at key intervals once the embedded culvert is installed. Culverts should be inspected after significant storm or runoff events. Inspections should check to see if there is debris clogging the culvert, if the appropriate substrate is still in place within the culvert, and to ensure there is no scouring at the culvert's outlet. If there are any issues with the embedded culvert, they should be remedied as soon as possible. Permanent marker stakes should be installed at each end of the embedded culvert to prevent damage from road maintenance equipment. Embedded culverts are superior to non-embedded culverts, as they are able to better mimic the natural watercourse's attributes when they are installed and maintained correctly. Design and sizing are critical to proper watercourse crossing function. Before choosing and installing an embedded culvert, it is important to ensure that provincial and federal legislation requirements are being met, and that site conditions are ideal for this type of watercourse crossing structure.